Hi, everybody. And hello to all of you out there in YUI Blogland. How many of you have heard of JavaScript? Just curious. Just about everybody raise their hand. How many of you like JavaScript? Almost as many hands. How many of you hate JavaScript? It is a sometimes thing. JavaScript is a remarkably maligned language, in a few cases perhaps justifiably so. And it has, I think, a lot of loyal proponents, and it has a lot of vicious enemies. And it deserves a lot of its reputation. It's a very cluttered language, very muddled. It comes, I think, from its just having gone to market way, way too fast. You know, if you go back to 1985, Java was just coming out, and Java applets were going to change the world. Since we're not talking about Java much today, we can surmise that, in fact, it failed in its primary mission. Java applets turned out not to be a good way to write applications. And some brilliant people at Netscape at the time recognized that. And so they decided that we should make our own language, which is more compatible with what we think are going to be the requirements of our browser, and promote that. And so Brendan Eich at Netscape, brilliant guy, came up with LiveScript. But it was done in a really, really big hurry. And as a result, I don't think anybody ever got a chance to write any significant programs in it before it was released to the world. And in fact, I don't think they anticipated at the time that the language was designed that people would write significant applications in it. At that time, no one had ever written an interactive browser application. And the sorts of things that Netscape 2 provided allowed for rollovers and a little bit of form validation and not much else. So JavaScript at that time, as it was called, was pretty anemic. And it was also intentionally mispositioned in order to not take too much Java's glory away. When I looked at the language when it was first announced, I pronounced it as incompetent and stupid. Like, what are they thinking? How could they possibly be doing this? And I think at the time, my judgment was right. If you look at the JavaScript 1.0 language, there really wasn't much of interest in it. Some of the features that it did have were seriously broken. Like, it was clear even then that overloading plus to mean both addition and concatenation was just a mistake. Just a mistake. And it was going to cause a lot of people problems over the years. And in fact, it has caused a lot of bugs over the years. Another problem that was clear from the outset was semicolon insertion. Nice idea. The idea was that syntax is complicated, particularly C syntax is complicated, and it's not always clear to people when a statement needs a semicolon on the end. And so the solution they came up with was, well, if one was needed and one was left out, we'll just stick it in, which was nice. But it would have been better had they designed a syntax that didn't require semicolons at all. Having the compiler automatically insert semicolons into the code tends to mask certain classes of errors. It just makes it dangerous. They shouldn't have done that. So I stopped looking at JavaScript from that point on and didn't pay any attention to it until about 5 years later. I was the CTO of a company called communities.com. We were doing communities on the net back when it looked like there was money to be made in that. And we landed a contract with Turner Broadcasting. They wanted to build an online collectible card game that kids could play based on Cartoon Network. And at that time, we had an offering called The Palace, which was graphical chat. The idea was that we could apply our graphical chat client to this collectible kids game, which would have been great. Except I went out to Atlanta and reviewed the requirements and became clear that The Palace just wasn't good enough to do that. And I was like, this is a $3 million contract. We didn't really want to say, sorry, we can't do it. So is there some other way that we could get this done really fast? So I took another look at the web browser and at JavaScript, and just wondering, is it good enough to do this? So I wrote a prototype in which we put a bunch of cartoon characters on a page and dragged them around and did stuff with them. And I took that prototype to Atlanta and showed them, and they said, oh yeah, that'll work. That's good enough. So I was like, wow, suddenly we're in the JavaScript business. So I went back to my team, brilliant Java developers, some of the best in the world at the time. said, okay, who wants to learn JavaScript? And everybody took a step backward. So the thing I was faced with at that moment was either I had to do all of that stuff or I was going to have to give the $3 million back. So like, talk about motivation. So suddenly I was a JavaScript programmer. And I began programming JavaScript the same way everybody else who begins using JavaScript didn't learn it. Just tried to figure it out, trial and error. It was like, there's not enough here worth having to learn it. Just fumble around with it. That's not true of any other language. Every other language that I've ever attempted, I would learn it, and I would learn it deep, and I'd learn it good. JavaScript was the only language I ever encountered where I should be able to fake it. And I don't know why JavaScript has that aspect about it, but I find that's pretty much universal. Most of the people who start using JavaScript really don't bother to learn it. But they expect it to work anyway, and then often they're disappointed when it doesn't work the way they thought it should, when they had no reason to expect that it should work the way they should. Programming is really serious business, and it should never be undertaken in ignorance. But for some reason, JavaScript seems to promote that sort of program in ignorance attitude. So at some point I decided I need to stop that because it really isn't very productive. We need to, JavaScript requires at least as much discipline and rigor and knowledge as any other programming language. It's not exceptional in that way at all. So anyway, we did this project with Turner, delivered it on time and under budget. We actually made the only money that company ever made. So that was great. And in the process, I learned a lot about JavaScript. We then spent all that money, and then we were out of business, and started another company right after that called State Software, in which we're going to take the things we'd learned doing the Turner project and apply them to enterprise applications. We were doing what you would now call AJAX. And we developed this brilliant application framework and a brilliant server technology that would work in a JavaScript environment, and we were doing really good stuff with that. It was there that I discovered JSON. We needed a way of communicating data between our client and our server. And we looked at the formats that were available at the time. XML was the most obvious choice. But we looked at it and said, man, this is just awful. It's ugly, it's really hard to deal with, it's expensive to parse it. It doesn't look anything like our data, so we have these weird transformations that go into data space, into document space, and then back into data space. It's like, we don't want to be in document space. We just like to have data go into data. And then I discovered that JavaScript had the notation that we wanted built into it. JavaScript's object literals were perfect for the mechanism for transferring data. And I convinced the guys I was working with that, yeah, this is the way to do it. History should note that the very first JSON message that we sent between our client and between our server and our JavaScript client failed. And the reason was one of the names in the message was do, because our messages were addressed to objects, and do was the thing containing the method that we wanted run. And it turns out do is a reserved word in JavaScript. And one of the design errors in JavaScript was you can't put a reserved word in the name part of an object literal. There's absolutely no excuse for that. That was just stupid. It was just a bug. That never got fixed, got put in the standard. It's in all the implementations. And it tripped us up, because there's no reason to think that you had to put quotes around the word do. So if you've ever looked at JSON and wondered, why is it you have to put quotes around all the names? That's why. It's because of this error in JavaScript. And when I started writing the specification for JSON, which is about that big, it's really simple. One of my goals in writing the standard for JSON was, how small can I make it? And my thinking was, in creating a standard, the less we have to agree on in order to interact, then the more likely we're going to be able to interact successfully. If you start having a whole lot of detail and a whole lot of optional stuff and a whole lot of complexity, the likelihood that we're going to be able to just work together is greatly diminished. So I tried to make JSON as small as possible. And one way I could have written it was, you can leave the quotes off of names as long as it's not one of the names on this list, and then have this surprisingly long list of JavaScript reserved words. But I didn't want to do that because at the time, JavaScript had a horrible reputation. And to be announcing a data format based on a language that everybody hates was kind of an odd thing to be trying to do in 2002. But even more than that, to put into the specification, and here are the really stupid things in JavaScript, by the way. So my thinking was, let's just kind of ignore or hide these stupidities in JavaScript so that people don't have to be aware of that in order to use JSON. And so we did that. About 5 years later, which is about now, JSON's huge. JSON is now the world's preferred way of doing data transmission, in AJAX applications, and increasingly in other sorts of applications. The XML community pretty much caved a few months ago. They put up a really strong defense against JSON, but it just collapsed. There's now some opinion that, okay, so for a lot of this stuff, JSON makes sense. And some of the XML guys are now saying any damn fool could design a better data format than XML, which is true, and I have an existence proof. But they're still saying, but really complicated, super complicated applications still need it. So you're allowed to use JSON if you want to, but you still have to use XML for the complicated stuff. I've still not discovered what that complicated case is. And eventually, I think everyone else will discover that's true. So JSON and some of the new data formats that JSON has inspired, I think, are just going to replace it. While I was doing all this stuff, I discovered some things about JavaScript. I discovered that it had some seriously good ideas behind it, some seriously good ideas. It has lambdas in it. It has functions as values. This was something that was first put into Lisp and perfected in Scheme. It's a concept in AI languages. It's in JavaScript, an in-page scripting language. How did that happen? JavaScript is the first Lambda language to go mainstream. And the MIT and the Lisp, the AI community has been trying to push their stuff into the mainstream since 1958, and have still failed. JavaScript succeeded. JavaScript is now the most popular programming language in the world, largely as a result of being in browsers and in confabulators and a lot of other really cool things. There are more JavaScript execution platforms out there than for any other language, by a very large margin now. So JavaScript succeeded, and it has this wonderful functional nature in it. And I was, for a time, I think, the only person in the world who seemed to be aware of that. If you look at the documentation from Netscape at the time, and even looking at some of the stuff you get from Mozilla now, really not much mention in it, and where it is mentioned, not much appreciation of it. So just thinking about the language and going, my God, there are lambdas in here. What does that mean? It meant, for one thing, that we have private variables in JavaScript, which is something we didn't know that we had before. That there are patterns by using lambdas and closures. We can encapsulate the guts of a function and hide its values and have those values available to methods. So it means we now have private members in objects, which is something JavaScript doesn't have, but it has, and it has because of this lambda nature. So that was great. So I started promoting this stuff, saying, hey, anybody know this is actually a really good language because it's got these features? And slowly the reputation of JavaScript started to improve. And JavaScript has other good ideas in it. It's got the object literals, which became the basis of JSON. Brilliant idea, just wonderful. It turns out that Python has the same feature in it. I think Python put it in coincidentally. And also NewtonScript has it. Not that anybody cares anymore about NewtonScript, but it just happened to have the same notation. And I think these three languages all did it the same way just because it's a natural representation for data in a modern programming language. It's just right. So in that sense, JavaScript is a little bit ahead of the curve in sort of recognizing or anticipating where the C family of languages are going. We're now starting to see some of JavaScript's features going back into Python and into C# and to some other languages. For a language with a terrible reputation, it's surprisingly influential among language designers. JavaScript also has dynamic objects, which are another brilliant thing, in which we don't have classes, we just have an object, which is a general container, and you can stick anything in it and get anything out of it, and you can take those first-class functions and put them in there, and they work like methods. Just absolutely brilliant. So simple, so elegant, amazingly powerful. Not quite implemented right. It's like 95% of the way there. Some of the prototype nature interferes with the use of them as general containers, and it's unfortunate that the language didn't get it right, but it got it mostly right, enough to make it usable. The language also has some seriously bad ideas. There's a lot of brokenness in the language. There's some broken syntax and some broken features and traps for the unwary. But there's also at least one supremely bad idea. And that idea is global variables as the mechanism of linkage of different compilation units. So in most languages, you compile something into an intermediate form, and then you have a linker which combines all those together, and it knits the labels together, and everything works. JavaScript doesn't do that. It's load and go. So you deliver source program to the execution site, it gets compiled and run. But if you have multiple units, how do you get them to work together? And the way they came up with was the simplest thing you can do, and possibly also the worst thing you can do, which is you take all the variables that you define and you stick them all into one common global space. And that's bad for a whole lot of reasons. It's bad for reliability because it means, well, first off, global variables are evil. They just are. We all know that, but we still keep making programming languages that have global variables in them because they're useful, but they are attractive nuisances. They are traps. They can cause you to do bad stuff. And JavaScript actually takes it even further. JavaScript has implied global variables. So if you use a variable and you forget to define it by putting var in front of it at least once, JavaScript assumes, oh, you meant a global variable, which is the worst possible thing it could do. It's very common if you have an API with, say, the word I in it. It's pretty likely that somebody else in the world is going to have a for loop in which they forgot to put var in front of it, and boom, things start getting smashed. And those sorts of bugs are really hard to debug. And it's the kind of error that is extremely easy for a compiler to find. Like, hey, you forgot to define that. I mean, compilers love doing that. But JavaScript's definition prevents the compiler from reporting that error. Really bad mistake. But it turns out that it's an even more significant mistake now because we're mashing up now. So at the time that Netscape was designed, no one had ever imagined mashups. So the assumption was that all of the script units are going to be coming from the same source, and they're all equally trusted, and they all go into the same global pool, and they're all allowed to interact there. And that's not true anymore. We now have some things coming from Yahoo and some things from Google and some things from someone else, and they're all going into the same page or the same application space. And there's absolutely no way to defend any of these components from any of the others. Every one of them has access to all of the global variables of everybody else, and they have access in the browser to the DOM nodes of everybody else. So what that means is today, mashups are not acceptable in cases where there is any confidential information on the page anywhere, including the ID of the user who got the first page. For a lot of the mashups we're seeing, that doesn't matter. I want to take a calendar of events and compare it against a map and mash that up. That's fine. There's no confidential information in that. But if there's anything that's about me that's going into that, then it's not indicated. And this is a big problem. It's a really seriously big problem. So I've been doing all this stuff with JavaScript and trying to figure out how do we use JavaScript most effectively? How do we make it safer? How do we make it more productive? And there are a whole lot of good intentions in JavaScript, things which just didn't work out very well, things which you could say are broken. Like there's a with statement which tries to do dynamic scoping in a system which really wants to be doing static scoping, and it makes the programs really inefficient, but worse than that, it doesn't work. It's buggy. It fails in common cases. So what do you do with that? How do you make it work? Well, the thing that I figured out to make it work was don't use it. It turns out it's really not very useful in the first place. There are much better substitutes in the language. Like if there's a complicated path that gets me to an object that I want to look at multiple times, I'll just take the result of that path and put it in a variable, and then I can access it through that variable as many times as I want. And that's really fast. It turns out to be an optimization. It also reads better, and there's no ambiguity, so it avoids bugs. So I started looking at what is in the language that I can take out in order to make it more effective. And it turns out there's a lot of that stuff in language. And JavaScript is a very cluttered language, and it's really easy to clean it up. And at some point, I realized I needed a tool to help me do that because there's so much stuff, so much clutter in the language, it was really hard to find it all myself. When I discovered that JavaScript had this lambda nature to it, I remembered a paper I had read by Von Pratt, who I think was at MIT at the time. He's now at Stanford University, describing a parsing technique which was amazingly simple and really fast and very expressive, but it required a functional language in order to implement it effectively. And so he showed how to implement it in Lisp, and it was brilliant. But the people who do Lisp don't like syntax. They like S expressions, which are horrendous, and that's why Lisp never went mainstream, because nobody wants to look at that stuff. But now I had a functional programming language with syntax. So I was now in a world where syntax was good, and I had a functional language which could implement Pratt's algorithm. So I wrote a compiler in JavaScript which would compiler JavaScript using Pratt's technique. I was like, wow, you could do that. JavaScript is good enough to write its own compiler. That's sometimes one of the tests of a programming language. And I was like, now what do I do with that? And so I put it on the web, and I called it JSLint. And so what it does is it compiles your program and produces a parse tree of it. And while it's doing that, it is looking for all of these bad parts that are in JavaScript, weak things in the design, things which would inspire you to go off the rails and do something dangerous. So JavaScript, or JSLint, defines what I call a professional subset of JavaScript. It's just the good parts, and maybe a few of the bad parts that are unavoidable, but mostly it's just the good parts. And if you take your program and run it through, it'll point out all of the things that I think are wrong with it. First thing I have to tell you is it can really hurt your feelings. And I know this because it's hurt my feelings, and I wrote it. As I've been working with it over the years, I've been discovering more and more traps. I go around our properties here at Yahoo, and I hear a lot from people out in the field, and I look at complang JavaScript, which is still an ongoing thing. It's the only thing in Usenet I look at anymore. And look at the sorts of patterns of mistakes that people make, and put them into JSLint, so that we've got an automated form to check them. One of the things about JavaScript is it's a dynamic language, or with dynamic typing, or loose typing, that any variable can contain any value of any type, which is not a popular mode of doing things now. Most of the popular languages today have strict typing, so that a variable can only contain a thing of a specific type or something which conforms to a specific type. And the theory for why that's important is that it allows the compiler to check a large class of errors at compile time. And so by checking those errors at compile time, they don't happen later where they're more expensive to find. And that's good, and I used to really believe in that. But working with JavaScript has changed my mind on that, because it turns out you still have to test. Having a type-checking compiler doesn't relieve you of the responsibility to test your code and make sure it actually does what you intend it to do. And I've found that the class of errors that type-checking catches aren't the kinds of errors that I make. And when I do make them, they turn out to be really easy to find. The really hard problems that make debugging complicated and difficult, I find I make more of them in a language with strong type checking than I do in JavaScript. Maybe it's because JavaScript is easier to debug because of its dynamic nature, or it may be that I spend less time working against the type system. I'd never have to cast in JavaScript because everything is object, and so everything's compatible. It doesn't matter what an object's lineage is. What matters is the quality of its contents. And that's a really easy thing to inspect in a test or to inspect in a debugger. So so I lose the benefit of some compile time checking, but I gain enormous expressive power because I'm not working against the type system. I'm never casting. I'm never designing complex hierarchies. Sometimes I see people coming to JavaScript from Java, and they bring with them the sensibilities for how you design in Java. And they've got these really complex hierarchies that go really, really deep. And you just don't do that stuff in JavaScript. JavaScript doesn't like it. JavaScript will punish you if you try to program that way. JavaScript likes stuff which is light and minimal and shallow. JavaScript just, so your programs just become bits of fluff, which sustain themselves, and they work, rather than being a whole lot of plumbing and a whole lot of infrastructure and scaffolding. It's just a little bit of stuff that works. So for doing things like widgets, where you just want a little bit of stuff and have it work, JavaScript turns out to be a really useful language. And so JavaScript has radically changed my way of thinking about programming languages. I really like the dynamic nature of it. Checking for dynamism, huge benefit. Really, really like it. Once you learn to think in JavaScript, I found it completely changed the way I program. Not only that, it made me a better Java programmer. So when I go back and I'm working in the classical languages, I find I'm writing lighter in that environment too, even though it's an environment that encourages very profoundly heavy programming. Just thinking in terms of lambdas and functions and thinking about security, even though JavaScript is not a secure language. Some of the patterns in which you do information hiding in JavaScript could ultimately be employed in a secure programming language. And I find it makes the programs cleaner. That good security design is just good design. And JavaScript, in an interesting way, can encourage that. So I wrote this compiler for JavaScript in JavaScript. And I was disappointed that it didn't run really, really fast. It should have run really, really fast. And because Pratt's technique is just so elegant. You do almost nothing on each token, but it all just because of the way these functions recurs and get bound together, it comes out with a parse tree, which is just perfect. So I looked at, well, why isn't it fast? And it turns out that all of the JavaScript systems that are available were all designed for quick time to market. Like all of them. I mean, the original Netscape system went from introduction to global domination almost instantly, faster than any other language in history. And that's really too bad, because they never had a chance to use the language before it went out there. C at least had a chance to kick around Bell Labs for a few years before it went public. And even then, it went out with known bugs in it. For example, the ampersand operator has the wrong precedence. And that's why you always need to use parens whenever you're using an ampersand. And the reason for that was the double ampersand operator got invented a little bit later. And it was partly inspired by people misusing the bitwise ampersand operator to do logical ands. And in order not to break the programs of the dozen or so programmers who were working in the lab at that time, they got it wrong and shipped it that way to the public. JavaScript went way beyond that. So it had been virtually unused, and then it went out there. And in the first version, it was pretty awful. But then in JavaScript 1.2, they added some amazing things. They added the functions then, the lambda nature, and they added the object literals, and stuff that I took no notice of at the time, but which in retrospect, I think, man, that was a damn good set of choices that he put into the language. I think it made the language good. Not that it makes any difference what I think, because JavaScript is the most popular language in the world, completely independent of its qualities as a programming language. You know, it's not in every browser, and it's not in every place else because it's so good. It's there because it's there. I mean, it's sort of the proof that it's better to be lucky than smart. You know, JavaScript was in exactly the right place at the right time, and for no other reason, it's gotten good, or it's gotten popular. The lucky thing for us is it's actually a good language, and given the way that standards are set in the web, that's way better than we deserve. You know, things get adopted for really bad reasons, and JavaScript got adopted for all the wrong reasons, but it turns out it's really good, and I really like JavaScript. So I've been on a standards committee that's looking at the next version of JavaScript. And it's really hard, because you have the problem where you don't want to break existing programs, but the current language is broken. And how do you fix the language without breaking the things that it's dependent on? And ultimately, I don't think there's a solution to that. So there's a debate going on in the committee right now. How extensive a set of changes should we be making? You know, there's a lot of demand in the world, particularly from people who don't use JavaScript, to add static typing and classes and stuff like that. We could go and put those in the language, make the language much bigger and much more complicated, and the chance that maybe it'll finally take off. Or there's the other opinion, which I agree with, which is we should be really cautious about what we put in the language, because we are dependent on it, particularly in the web, where as a developer you don't get to choose what platform you get to run on. You have to run on all of the above, including all versions of all of the above for all time. And so the best thing to happen in JavaScript, the best feature that was ever added to JavaScript, was in 1999 when they published the third edition of ECMAScript, which froze the standard at that point, and they did nothing since. It turns out nothing happening is really, really good for software developers. We don't tend to think of it that way because we're always kind of stumbling around the things which are missing in the platform, and we're always looking forward to new features which might someday make our lives easier or allow us to have capabilities that we don't have now. But one of the things we learned in the browser wars was that having everything changing on you frequently and incompatibly and unpredictably makes programming really, really hard. And the web in that sense is unlike any other programming platform ever in history. I used to say it was the most hostile programming environment ever devised, but that was before I found out about mobile. Mobile is way, way worse than the web. Although we're now looking at mobile going to the web, so maybe it'll only become that bad. I guess that'd be a big improvement for mobile. So we can recognize that JavaScript is full of bugs. But the standards groups can't do anything about it. So the things that are most wrong with JavaScript, like its syntax is funky, and worst of all, the thing about global variables, that's terrible. Can't do anything about it, because if we did something about it, everything out there would break, and that would be the worst possible thing we could do. So standards body is incapable of fixing the things that are wrong with the language. They can do nothing about the bad parts. But you can. You as a developer, you have a choice. So as you address the language, you get to pick the set of features of the language that you're going to employ. When I started off as a programmer, I would study the language that I was using and learn everything about what it could do. And I would figure out every feature the language had, and I would figure out how to use every one of those features every time I went out and programmed. I think I was doing that mainly just to show off. I'm in total control of the universe. I can wield everything, every feature. And sometimes people would come to me and say, hey, I don't understand this feature. Can you explain it to me? And of course I can, because I use every feature every day. I can tell you about all that stuff. Since then, well, I'm always learning, always trying to figure out what is it that I don't know that I need to know in order to do what I do better. And in JavaScript, a lot of it came from experimentation and then later reflection. How do we make this language work better? And the thing that I figured out was it's easier to write programs if you're only using the good parts of the programming language. It's hard to make good things out of bad parts. So I, as a programmer, can make choices that the standards committee cannot make. I can say, OK, I'm just going to use the good parts. And I'm going to pretend that the bad parts don't exist. And it works. And I think as a consequence of that, I'm writing better programs. Every once in a while, I'll take JSLint and run it against stuff that I wrote a year or two ago. I'm always shocked at what it turns out. A year ago, I thought that was a good idea. And it clearly isn't now. And the thing that's changed is my appreciation of what the good parts are and what the bad parts are. And over time, I find more and more JavaScript moves from the good parts category into the bad parts category. But what's left in the good parts category keeps getting better. So I'm continuing to refine the language just to find that part of it that works really, really well. It's much the way that Michelangelo would address a piece of marble, where he would just chip away all of the bits of the marble that weren't beautiful, and what would be left would be a work of art. I think there actually is a work of art hidden inside of JavaScript. And it's there for everybody to find and to use. You just have to get past the bad parts. And again, the tool that I find is most effective for getting past the bad parts is JSLint. JSLint, I'm now recognizing, is a JavaScript good parts compiler. So JSLint knows what the good parts of JavaScript are. And if it sees anything in your program which is not a good part, it'll flag it for you. JavaScript is also a widget. So you can run it like any other widget. You can either paste a URL into it, and it'll go out onto the web and pull something in and then tell you how bad it is. Or you can drag some text onto it, and it'll do the analysis and print out a report and show you all the stuff, and in the process also show you where your global variables are and other things that may be unfortunate about your program, and give you the opportunity to fix them. So in doing that, I've found a way to be really happy about JavaScript. And I hope someday to make everybody happy about JavaScript, because I think it is seriously maligned, but I think it is seriously good. And using good tools, we can do good stuff. So that's it. That's all I have to say. Thank you, everybody.